Thank you, Nadia.
Thank you. All right. So boys and girls, I just want to introduce myself. My name is Miss Nadia, and I am a teacher. I've taught many grades. So I've taught everything from kindergarten, grade 1, 2, 3, 4, 5, 6, 7, and 8. I've taught high school. And one of my favorite grades has always been grade 1, grade 2, grade 3, and grade 4, just because I love the primary grades. So boys, today we are going to be learning a bit about number sense. And when I mean number sense, I mean, how numbers make sense. Yeah, something like that. We're also going to learn about how numbers make meaning in terms of place value. So I'm assuming that you all know what place value is, correct? Right? Place value is when we place, if we have like a 3-digit number, one of those digits belong to the hundreds column, one belongs to the tens column, one belongs to the ones column. Okay, guys? So let's take a look now. So today we're going to explore not hundreds numbers. We're going to explore 2-digit numbers, 3-digit numbers, 4-digit numbers. We're also going to explore 1,000-digit numbers. Boys, do you know how many numbers are in a 1,000-digit number? Michael?
That 6.
So in a 1,000-digit number, there's 6 numbers.
Yeah.
Are you sure about that? Because right now, if I were to write 1,000, it would be like this.
4.
And I don't think there's 6 digits here. How many digits are here?
4.
There's 4. In a 10,000 number, let's see how much we get now. How many digits are there now?
5.
5. Now let's look at 100,000-digit number, which is
6.
numbers that we don't normally go up to. You're right, there's 6. So if I make the 500,000 number, we got 6 digits, okay? So I'm going to erase this. And of course, let's hope that eraser works. Sometimes it does, sometimes it doesn't. Okay, so let's review our thousands, hundreds, and tens, place values, and ones. So we know that 10 tens make up a 10. Sorry, 10 ones make up a 10. We know that 10 tens make up 100. We also know that 10 hundreds make up 1,000. Let's look at the first problem, okay? Sam collected some marbles. So now this is a 3-digit number. He collected 3 hundreds, he collected 4 tens, and he collected 9 ones. So now I like the breakdown method that they show you this. They show you exactly how many were in hundreds. They show you exactly how many are in tens, and they show you exactly how many are in ones. There's 3 hundreds, there's 4 tens, there's 9 ones. His sister also collected some marbles. Let me just put this up here for you guys, okay? His sister also collected some marbles. 2 thousands, 4 hundreds, 3 tens, 5 ones. Boys, how would you say this number? How would you say the number? Michael.
2,435.
Good. And I want to just show you something. When I'm making numbers in the 1,000, I like to use a comma because I want people to practice a pause before they say the other numbers. So it really should sound like this: 2,000, pause, 435. Okay. This number is the exact same thing as saying 2,000 plus 400 plus 30 plus 35. And that's exactly how many marbles she collected. Okay, let's go to the next one. Oops. Now, 2,435 is written in standard form. This is called the expanded form. boys and girls, sorry, just boys here actually. Can you tell me what makes the expanded form different from the standard form? What makes the two different? Michael, Arthur, what makes the two different from each other? One is called standard, one's called expanded, but there's more than that. They're still the same numbers, but there's something that makes them different. What is that? Does anybody want to take a guess? Anybody at all? No? Okay, Arthur, how about you?
They add a zero to
Right.
how many it is.
Exactly. So if you're telling me a number is an expanded form, you have to show me that expanded forms. That means you got to write 2000 with the 3 zeros. You got to write 400 with the 2 zeros. You got to write 30 with the 1 0, and you got to write 5 as the single digit. Michael, I'm going to circle this. Can you tell me what number that is?
5,998.
Thank you so much. Arthur, I'm gonna circle this number right here. Can you tell me what number is that? What number is that?
I think it's 6,012.
Good. So can I ask you guys something? How many more numbers do you need to get to from 5,998 to 6,012? How many more numbers do you need? Does anybody know? Does anybody know? Michael.
2.
So from 5,998, if I add 2 numbers, I get 6,000. So again, I'm going to say the question to you again. Ready? How many more numbers do I need from 5,998 to get to 6,012? Michael.
14.
Do you agree with that, Arthur? Do you agree that we need 14 more numbers?
Yes.
Yes. So that is the correct. You know what? I find sometimes these questions are a little bit tricky. Tricky in the sense that they make you think. Sometimes it looks obvious and it might look a little bit easy. But you know what, guys? When we actually solve this and look at it and take a closer look, we realize that we kind of got to think. And sometimes we got to kind of think ahead before we say the answer, okay? All right, so let's look at the next part over here. As you can see, there's a little green text bubble, okay? And it says 5,998. 5,999, and then came 6,000. And then he jumped. He must have said a whole bunch of numbers here because I see commas and dots, commas and dots. His final answer was 6,012. Guys, they want you to count from 9,987 to 10,000. How many numbers do you need to get to 10,000 from 987? From 9,987. How many numbers do you need? Does anybody know? You can subtract these 2 numbers to find the difference. You can add on from these numbers to find the difference. So can somebody tell me? No, Michael, you didn't get it? Arthur, what about you?
I think it's 13.
So, and if we want to make sure that that answer is right, 7 plus 3 is 10. You carry the 1. 8 plus 1 is 9 plus 10. Good. And then you carry the 1 over here. You get 10 again. carry the 1 over here and you get 10 again. You are correct. The answer was 13. Okay, well done. Let's go over here now. It says count the thousands, the hundreds, the tens, and the ones. How good are you guys at counting place value? Are you guys good at it? Michael, what is this number?
3,274.
So 3,274. Arthur, do you agree that that's the right number?
Yes.
Good job. And in fact, it is. Now, here's what it looks like in expanded form. We see how it's written out with the zeros, 3,270 plus 4. What would this look like in standard form? Does anybody know? What would this look like in standard form? Michael?
Just zeros.
Say that again.
Just zero.
Just the zeros? Or do you mean take away the zeros?
Away zero.
Yeah, we got to take away the zeros. So it wouldn't be 3,000. It's just going to be a 3. It's not going to be 200. It's going to be a 2. It's not going to be a 70. It's going to be a 7. It's not going to be 4 ones. It's just going to be a 4. So 3,274. Okay. And both of them mean the exact same thing. Whether we add the zeros or we don't, we know what they mean. Okay, guys, let's go to the bottom here. Arthur, can you tell us what are the numbers in each box that we should put?
2,000. 0.
0 what? 0 hundreds?
0 hundreds.
Okay.
4 tenths.
Yeah.
5 ones.
Good. Michael, how would you say this number?
I would say 245.
Oh, it's not, but 2 is not in the hundreds place. It's a-
2,045.
Good. Can somebody show me how they would write it in the expanded form? Who wants to do it? Michael, go ahead.
Take away the zeros.
No. So in expanded form, you add zeros. So 2 is not 2 anymore. 2 under expanded is 2,000. Right? 0, because there's no 0 in hundreds, we keep that 0 just like that. We have 40 tens. And then we got 5 ones. So this is exactly what it's going to look like. Do you see that? Okay. All right. Perfect. Let's go to the next one. Can somebody tell me what number is this? Michael?
The number is 1,307.
Good job. How would I show this in expanded form, Arthur?
You add the zeros. The 1, you would add 3 zeros to the 1. You would add 2 zeros to the 3. The tens will still be a 0, and the 7 will be a 7.
Is it the exact same thing as 1,307, Arthur?
Yes.
Yeah, they're exactly the same. Only one has been expanded with its zeros. The other one has been shortened with no zeros. Okay, let's keep going now. I'm going to just erase these for us. All right. Michael, can you tell us this number right over here, please?
That is 4,205. and 50.
Good job. Arthur, can you please tell me what number is this?
I gotta go to the bank. Did you get your haircut?
Mhm.
Mary said she came knocking at the door 2 times here last
She didn't.
night. She did.
I told her I wasn't here.
Huh?
Sorry. So can somebody tell me what this number is?
6008.
Okay, good. Let's look at number 3. They want you to write this in standard form. Michael, what are the numbers I write?
Mm, you plus 0.
What's that?
You plus the 0.
So look what it says, 2,163. How do I write that number?
Minus the 0.
Okay, but you got to tell me what are the numbers I need.
You need 2,163.
So when I was asking for the numbers, really, the numbers I needed were 2, 1, 6, and a 3, correct? Okay, Arthur, what numbers do I need to make 8,008?
8008.
Good job. Michael, what numbers do I need to make 5,300?
5,300.
So it's 5,300. Okay. Next, Arthur, what numbers do I need to make 6,040?
6040.
Yeah. So when I'm asking you for the numbers, I'm not necessarily asking you for what place value in them. I just want to know what digit represents that place value, right? So we don't need to say hundreds, thousands, and eights. It's already set for us in the question. All they want to know is, hey, this is 2,000. Show me a number that represents 2,000. That's all. Okay, let's look at the next one, guys. This has been what I call the breakdown method, okay? So we have a number here that's in the 1,000 range, 6,824. I want to show you what they've done here. They've broken it down into thousands, hundreds, tens, and ones. The only problem we have right now is that we are missing the hundreds place. We're missing a number in the tens place. Arthur, what is missing in the 800?
800. 800.
Michael, what should I be putting in the blue square?
4.
So now do you see the progression of a place value numbers work? The biggest number is always at the front, then the middle number, and then your tens, and then your ones, right? 6,820 tens, 4 ones gives us a total of 6,824. Okay. 6,824 is a 4-digit number. The digit 2 stands for 20. So let's write this out. 6,824. Guys, just so you know, what I get my students to do sometimes is to make a place value chart. So that way they know exactly what value each digit holds in the number. For example, this is the 1,000 column. This is the hundreds column. This is the tens column, and this is the ones column. All right, let's get started. What does the 2-digit stand? The digit 2 stands for 20. We know that. The digit 6 stands for 6,000. What about the digit 8, Arthur? What does 8 stand for?
8 stands for 800.
Good. What about the 4? What does 4 stand for? It's very clear.
4.
For what? For
For
jelly
ones.
beans, for thousands?
For jelly bean?
Yeah. Does it stand for jelly beans?
4 ones.
For ones. There you go. Okay, I tried to trick you guys. All right, ready? What does the digit 5 stand for in each of the following numbers? So we're going to take these numbers and say, hey, is 5 1,000? Is 5 100? Is 5 a tens? Or is 5 a ones? Michael, let's start with you. Look at the 5 in question A.
100.
Good. Arthur, look at the 5 in question B.
Thousands.
Michael, look at the 5 in question C. Good job. All right, time to fill in the blanks. I'm just going, can somebody read me this number? What does this number sound like when you put it all together? Michael.
304.
Uh-oh, it's not 300.
3,468.
Good job. In the number 3,468, the digit 8 is in the ones place. As we know, its value is 8. The digit 6 is in the tens place. And as you guys know, the value is 60. The digit what is in the hundreds place? What digit is in the hundreds place? Arthur?
The digit 4 is in the hundreds
And its value is what, Arthur?
Its values is 400.
Thank you. Michael, the digit is blank in the thousand place. Which digit is in the thousands place?
The 7th place is a 3.
And what's the value of that 3? Is it 30? Is it 300? Is it 300?
3,000.
There we go. How many zeros is that, Michael?
That is 4.
Good job. All right, let's look at number 7. What is the value of each digit in 8,137? Ready? Michael, what's the value of the 3?
The value of the 3 is the 10th place.
Arthur, what's the value of the 7?
The 7 is in the ones place.
Michael, what's the value of the 1?
100.
And finally, Arthur, what's the value of the 10?
Thousands.
Okay. Can somebody tell me how many hundreds are in 6,241? Michael?
That's because
How many hundreds are in 6,241?
they're 200.
Now, can I ask you something, guys? Here they said that there are 6,200s in 6,241. How did they get that number? Because Michael, you are right. There's 200s there, but they're saying that there's 6,200s. How did they get this number, Michael?
It's because the 6 and the 2.
What about the 6 and the 2?
They put it together.
Okay, so if we put it together, that gives us 6,200, right?
Yeah.
And once we know that, once it's 6,200, there's a different way of saying it. It now becomes 6,200. Okay, how many tens are there in 6,241, Arthur?
4.
So there's 4 tens, right? I'm going to put 4 here. All right, let's look at the next one, guys. Fill in the blanks. 8,401 Michael has how many thousands?
There are 6,000.
Ooh, there you go.
I'm looking at C.
Oh, B, Arthur, is 1,903. How many hundreds are there?
9.
Thank you, Arthur. Michael, back to you. 6,514. How many tens in there?
5.
Good. 4,056, Arthur has how many ones?
4. I mean,
Try it
6.
again. There. Can somebody tell me the digits only? Ready? 3,015 tens. How would I write it as a numeral? Go ahead. Go, Michael.
I'll write it as 30015.
Interesting. You said 3. Say that again.
30000.
3000.
And 300
And what about 15?
15.
Arthur, I'm going to ask you, is this correct?
I don't really think so.
Okay, so I'm going to help you, Michael. Unfortunately, this is not. Yeah, hold on. Let me say something, okay? With this particular number, I'm going to show you something. Let me just use my eraser. Hopefully we can get rid of all these little marks here. Sometimes it works, and then sometimes she doesn't work. So today might be one of those decision days for her. Okay, so what ends up happening is when you have a number like 3,015, we don't write the whole 1,000 out, right? We got to remember that there's 3 other numbers in 1,000 number. So 3 represents 1,000. There's no need to write out any zeros at all. Do you have, hold on, do you have any hundreds? You don't have any hundreds. It's telling me that this number is comprised of 3,015. So that means in the 1,000 column, you got 3. In the hundreds column, you got 0. In the tens column, you got 15, which means you got 1 10. And in the ones column, you got 5 ones. This is what gives you the number 3,015. Arthur, Michael, do you agree with me?
Yes.
You do agree with me. Okay, so let's see now if we can get this erased. There we go. Some of it's been erased. Let's look at the next one. Arthur, I'm going to have you do the next one. Ready? It's asking for 20 hundreds, 60 tens, and 93 ones. How do you write that as a digit, Arthur, as 4 digits?
Two, 6, 9, 3.
2, 6, 9, 3. Is 20 hundreds the same as saying 2,000? Yes or no?
Yes.
Yes. So therefore 20 hundreds is equal to 2,000. 60 tens is equal to 6, right? 60, and then 600, and then we have 93 ones, which we would just write as 93. So you can actually write this number doing this, 2,693. Boys, I want to show you a little tip. And you've probably seen it before, but I do it just because I find it helpful, especially when you're saying numbers that are multi-digits. Now, look, I always put a comma between my thousands place number and my hundreds place number. Do you know why I put that comma? Can anybody tell me why you think I always use it? Michael.
Because there's another 0.
Yes, because, well, there's not another 0. It shows you that, hey, there's 4 digits here. I'm going to separate the 1,000 digit from all the other digits. So I'm going to separate 1,000 from 6, from 9, and 3. So that way, you know, there's 1,000 and then 3 other numbers that follow it. I also put a comma there for another reason. You know why? Because I want people to pause when they get to the comma. I want it to sound like this: 2,693. Because there's nothing worse than someone rushing a big digit number and going like this: 2,693, and then I can't hear it, and then I can't realize, what did you say? What were the numbers? So that comma also tells me to pause, but it also tells me to show the demarcation between what's in the thousands and what's in the hundreds, tens, and ones. Okay, let's go now to the next page. And I want you guys to look at these 2 boxes. Michael, I'm going to get you to look at this first box. And Arthur, I'm going to get you to look at the second box. So Michael, look at this box here. Arthur, look at this box. Arthur, what number do you have? Your box is showing what number?
264.
Good. Michael, your box is showing what number?
316.
Good. Which one is greater? Michael.
316.
Boys, what's the symbol we use to show that one number when we're comparing numbers? What's the symbol that's used to show that a number is bigger than another number? Michael?
With the hundreds.
So I kind of call it Pac-Man, right? I always say Pac-Man likes to chomp on the big number. So I'm going to show you what I use. I use this symbol. Oh, it's not even coming out. Hold on.
I got it, the alligator mouth.
Yes. And some people call it the crocodile chomp or the alligator chomp. But I know that the alligator always likes to eat bigger food, right? Look, I'm even going to put nice sharp teeth on him. Look at that. He's crunching up the big numbers.
He's trying to get mine.
What's that?
He's trying to get mine.
That's right. All right, let's look at the second one. Now, can I get Arthur? Can you tell us the number that this represents right here?
325.
Thank you. Michael, can you tell me what this number is represented as here?
352.
Which is smaller? Michael?
325.
Remember that the crocodile likes to chomp bigger numbers. This means that his back is going to be towards the smaller number. He's still going to have his crunchy old teeth like this, and he's going to be chomping up the bigger numbers. So 325 is smaller than 352. Can I ask you something? Let's see if you're critical thinkers. Look at the 2 numbers. What do they have in common? Does anybody can tell me what they have in common? Michael?
The 5 and the 2, they switched in place.
That's right. So look, the digits are the same. The value of the digits are different though. 3 is still 100 in both. 20 is in one, whereas 2 is, there's 2 ones in the other. Then we have 5 ones in the first number and then 5 tens in the second number. So the place value is a little bit different, right? Okay, let's go over here. Let's see if I could get back to my pen over here. I'm just going to erase all my drawings. Sometimes when I erase, it clears everything up and then we can move forward. Okay, perfect. And I'm just going to get rid of this. Okay, you guys ready?
Yeah.
Okay, let's get ready. Let's see if there it works. Ready? Arthur, this question is for you. Arthur, which is greater? Can you say these 2 numbers for me?
4,316
Or
4,264.
where am I putting Pac-Man's mouth?
facing 4,316.
Good job. Michael, you're next. Which is greater? Say these two numbers.
4,360
Or
5,264.
where am I putting Pac-Man's mouth?
5,264.
Arthur, look at the two numbers. Say them.
2,325 or 2,352.
Can you tell us which number is the smaller one?
The smaller one is 2,325.
Exactly. I'm going to put Pac-Man's mouth against that number because he only chomps big numbers. Michael, can you read the two numbers for us below?
3,325 or 2,352.
Michael, which number is smaller?
2,352.
Good job. Okay, so let's go over to some number patterns. Are you guys ready? Now, I like number patterns. Why? Because number patterns, we get to see patterns within patterns. And you know what I always tell my students, Michael and Arthur, that math is one big pattern of webs. That's all it is. It's a web of patterns. And what you need to do is just break through these webs, and then you will be able to solve problems without any glitches. But first of all, let's look at these patterns here. Arthur, read these words for us. These numbers, sorry.
5,342. 5,442. 5,542.
Stop right there. Arthur, get ready to answer this question. Is this an increasing pattern or a decreasing pattern?
This is an increasing pattern.
What is it increasing by each time?
100.
So what will be the next two numbers?
5,642.
And the next one?
5,742.
Excellent, thank you. Michael, you're gonna do the one just below that. Ready? Read me these numbers, go ahead.
5,342. 6,342. 7,342.
I'm gonna ask the same question I asked Arthur. Is this an increasing pattern or decreasing?
Increasing.
What is it increasing by each time?
1,000.
So what will be the next two numbers?
8,342.
Good, and the number after that?
9,342.
You got it. Okay, let's go to the next one. Arthur, read the numbers to me, please.
Okay. 5,342. 5,343. 5,344.
Arthur, we know that this is an increasing pattern, but I want to know by how much.
1.
So what would be the next two numbers?
Sorry, but I have to go to violin, but I'll answer this question real quick.
Okay,
The next will be 5,345 and then 5,346.
well done. So you have to go now, Arthur?
Yeah, sorry, I have to go.
Okay, you take care. Bye, Arthur. Thanks for joining us.
Bye.
Nice to see you and meet you. Bye.
Right, bye.
Bye. Okay, Michael, it's just you now. The pressure is on you. You're in the hot seat. All right, Michael, look at these numbers. The pattern increasing or is the pattern decreasing?
I know it's decreasing.
I'm gonna
Increasing, I mean.
disagree. Okay,
Increase.
Michael, I'm gonna ask you a trick question. Let's see if you get this. Which place value in the number is decreasing? Is it in the hundreds column, the thousands column, the tens, the ones, or what?
It is increased.
So this is called the thousands column. This is called the hundreds column. This is called the tens column. This is called the ones column. Which column is the number, which column is decreasing each time in the sequence? Look at the number that's bolded. Look at the numbers that are bolded. 5 is bolded, 6 is bolded, 4 is bolded. What
Tens.
place?
Tens.
They're in the tens. What will be the next 2 consecutive numbers? So look, I started out with 5,342. I moved up to 5,352. I move up again for 5,362. What's next?
5,372.
And after that?
392.
Not 92. This
82.
is, yeah, let's not count our chickens before they hatch, right? Ever heard that one? No. Okay. Look at this. I want you to look at the numbers here. Look how many thousands. Look how many tens. Look how many hundreds. And look how many ones. Michael, what number does this represent?
3,624.
Correct. 3,624. What number is 100 more than this? If I were to add 100 to this, what would be the answer?
That will be 3,724.
Good. I'm glad you said that because we would have to add in the hundreds column, not in the tens, not in the ones, not in the thousands, only in the hundreds. Okay. All right. What number is one more than 3,624? Can you tell me?
One more than 3,624 is 3,625.
Good. Listen to this. What number is 10 more than 3,624?
3,634.
Wonderful. Ready? What number is 1,000 more than 3,624?
4,624.
Good job. All right, let's look at the next one, Michael. What number is less than 5,000? Sorry, is 1,000 less than a 5,732?
4,732.
Now, what method did you use to find that? What did you use? What did you say to yourself? What calculation did you need to do?
Subtraction.
You needed to subtract. What did you subtract from? Can you tell us?
1,000.
From what?
From 1,000.
From 5,732, correct?
Yeah.
Okay. Give me one number less than 5,732. Can you do that? One number, oops, I went a little bit high here. One number less than that. Can you do that?
5,731.
Good. Give me 10 less than 5,732.
Well, that is 5,722.
Perfect. Listen carefully. What number is 100 less than 5,732?
5,632.
Good job, Macau. All right, Michael, now that I know that you know some number patterns, let's see if you can complete these ones. Ready? Michael, can you tell me if these are decreasing pattern or increasing patterns? Is this increasing or decreasing?
Decreasing.
Uh-oh, try again.
Decreasing.
I say increasing, right? Because the numbers are getting bigger each time I see them. What should be right here, Michael? I know it's still going to be a 3,000, but it's not going to be a 0.
3,100.
Excellent. So we see that now the ones column is changing, right? After we've put that 100. Okay, let's keep going on this one. It's always best when you look at a number sequence or a number pattern like this. The first thing you need to do is figure out if it's an increasing or decreasing pattern. So right over here, is this growing or is this shrinking?
It is shrinking.
Think again. 98, 108, 118, 138. It's in.
Decreasing.
Uh-oh, it's not +8.
I said
What are they adding
+8.
each time?
We're adding. We are adding 10.
That's right. 98 plus 10 gives us 3,108. Sorry. 3,108 plus 10 gives us 3,118. 3,118 plus 10 gives us what, Michael?
That gives us 300.
No, you keep saying 100 and I'm saying no because I know that.
3,000.
Yes.
3,128.
Okay, let me write these digits again. You know what? The digits are right, but the way they're pronounced, we're going to go back and work on that. Go ahead. Say it again. 3,000.
3,128.
Good. See, now you're getting it. All right. Again, look at the pattern before you do anything. Tell me, is this growing or shrinking?
Growing.
It's a growing pattern. What comes after 3,098?
4,098.
And so does it follow a pattern? Michael, look, 5,098, 6,098. I'm going to ask you a question. Ready? In this particular pattern, Michael, which place value was the only place value that was changing each time? Was it the thousand place, the hundreds, the tens, or the ones? The thousands place. All right, let's go to D. Is this an increasing pattern or a decreasing pattern?
Increasing.
And what is it increasing by? Look at the first two numbers. It went from
100.
Good. So what would this next number be, our mystery number here?
It is.
We still need that 3,000 there, buddy.
3,298.
You got it right, sir. And now the next numbers, can you read this number for me?
3,398.
398. And read the last number for me.
3,498.
Good job. So now, do you see sometimes that when patterns are increasing in numbers, It's not always the total number. It's just maybe a certain value or part of the number, okay? All right. Ooh, look at this one. Okay, I want you to look at this pattern. Don't bother with the green blank one yet because there's something I got to show you that's important. Look at the numbers. Are they getting bigger or are they getting smaller? Yeah, they're decreasing. So what are they decreasing by each time? Can you tell me?
Decreasing by the hundreds.
So minus 100 is 893. Minus another 100 would give us 7,793. Minus 100 would give us 693. But what did they start with? That's what I want to know.
They started with 8,000.
And what? If it's 100, decreasing by 100 each time, this would have been 100 more than 7,993. So what's 100 more than 7,993?
8,003.
No. Try it again. So look, here's your number, 7,993. If we add 100 to this number, what does it become?
It becomes
3 plus 0 is 3. 9 plus 0 is 9. 9 plus 1 is 10.
8.
Carry it over, and what do you get?
8,093.
Or is it 8,803? Hold on. We got to minus this, right? Wait a minute. Let's do this again. 7,900, because I'm pretty sure the answer here would be, oh yeah, you're right. You're absolutely right. 8,093, because what happens if we had 100 to 7,993, we would get 8,993, right? Correct? And 7,993 subtracted by 100 gives us what, Michael?
Gives us 8,000.
It gives us 398,000. Sorry, and it gives us 7,893. So we're on the right track, okay? All right. Have you rounded numbers before, Michael? Do you know what rounding numbers means, Michael? Okay, let me give you an example. Michael, when we round numbers, sometimes we have to round them to the nearest 10th, or sometimes we have to round them up to the nearest 20th, to the nearest 100th. So sometimes where numbers get rounded down because they're just too small, or sometimes numbers get rounded up because they're just so big. Now, usually when I round numbers, I give students two numbers to work with. So for example, 61. I always say, listen, what's the closest 10th to 61? Is it 60 or is it 70?
60.
Because yes, so this is something we would round down. Look at 68. Again, I'm going to, instead of the 8-1, I'm going to put an 8. Is it closer to 70 or is it closer to 60?
70.
Yes. Now here comes a bit of a one with a little bit of a rule to it. Let me explain this. You have 75. Michael, that's the halfway mark from 70 to 80. Does it get rounded up or does it get rounded down?
Rounded down.
So we have a rule in math, okay, that when you're in a predicament like this and you have a number that ends with 5, you have to round it up. And I'm going to tell you why this rule. Yes, it would be 80. Michael, this rule applies to all number that ends with 5 or higher numbers. So 75 would get rounded up to 80. So would have 76. So would 77. So would 78. So would 79. And so would 80, right? They'd all get rounded up to 80. Michael, what if I did this to you? I'm going to give you 70. I'm going to put 80, and I'm going to give you the number 73. Are you going to round it down, or are you going to round it up? Down.
Yeah.
Why do you say that? Can you tell me?
It is because 70 plus 3 equals 73. So 73 need to plus 7 to get to 80. 7 is less than 80.
Right. So here's the rule I'm going to leave you with today. Michael, any numbers that end with, ready? Let me write this down for you. Any numbers that end with a 0, with a 1, with a 2, a 3, or a 4, we round them down. We do not round up until we get to 5. So 70, 71, 72, 73, 74, these are all numbers that would get rounded down to 70. Anything 75 and over gets rounded up. That's why I said 5 is a special number in math, Michael, because that particular number is going to be the determinant whether you either go up with rounding or you go down with rounding. And like I say, once we come to 5, that's it. We've hit the threshold. We start rounding up. Okay. All right. Let's look over here. This is called, do you know what this is called when numbers are on our line like this? It's called a number line, right? And I want you to look at this number line. This number line is spaced. You see these little dashes? The dashes between the number line are tens. So we have 55 here. We have 65 that goes here. We have 70 that goes here, 75, 80, 85, and then 90. Sometimes, Michael, when we're rounding up, it's easier to look at a number line. Look at 68. Is it closer to 60 or is it closer to 70?
68 closer than to 7.
Yeah. How about let's look at 61. Is it closer to 60 or is it closer to 70?
60.
So this is why people use number lines, because what they do, Michael, is they plot these numbers on the number line and they say, hey, I could see just from skip jumping, I can see who's closer to which number. 61's closer to 60, so I'm going to round it down. 68 is closer to 70. That means I got to round it up. So whenever we see a number that ends with a 5, we round it up. Now, Michael, you did very well in today's session. And I'm curious to know, how did you find it? Was it challenging? Was it easy, difficult, medium? How did you find it?
I find it easy.
So maybe next time we got to give Michael some more challenges. What does that sound like? Does that sound like a plan to you?
Yeah.
Yeah, we'll give you more challenges, okay?
Even though I would play checker than chess.
But sometimes reviews are good for us too, Michael, right? I know that sometimes when we're not doing the same math all the time, especially because school, we move units very quickly, we often forget some of these rules and some of this underlying knowledge that we have in math. So yeah, that's why sometimes it's important just to stop everything and review and make sure we know before we move forward, okay? Well, I'm going to wish you a great day. And if I don't see you, a Merry Christmas and a Happy
New Year.
All right, Michael, you have a great day, okay?
Okay.
Bye, Michael.
Bye.
Bye, sweetheart.
Bye.
Bye.